So this is divergence of d. So see here the derivation. How do we get the derivation divergence of d? That is d means flux density. So this is one of the application of Gauss law. That is differential volume element. So here, if you consider this is the x coordinate and y coordinate and z coordinate, and this is the block, we have a volume charge density, and in this we have a point P where P x comma y comma z, where the flux density or intensity is assumed to be like this d naught of x, because it's a center. That's why we denoted as d naught of x is equals to dx naught dx0 ax dy0 ay dz0 az. So this is the having a flux density here it point x comma y comma z, and it is having a coefficients of dx naught in the direction of ax, dy naught in the direction of ay, dx naught in the direction of az. So we have assumed that. So for this, since the charge flux is there, then definitely it comes out uh, flux density, flux lines in this direction, front direction, in the back direction of the, and similarly this is the right direction flux, and this is left direction flux, and this is the top direction flux and bottom direction flux. So in all directions it spreads flux lines. So now we need to calculate them mathematically, and what should be the and how to do it in the mathematics. Let us consider. So in the first case, already we know that as per the Gauss law, integral, actually this is surface integral d dot s ds is equal to q. This is the Gauss law statement. The total amount of charge enclosed in the body is equal to total flux emitting from the body. This is the ds, capital D s ds is equal to q. That is total. Since we have in the four directions, front, back, right side and left side and top and bottom, so then we have considered into segregate and separation of integrals. So ds of ds is q is equals to d integral front plus d integral back plus d integral left plus d integral right plus d integral top plus d integral bottom. This is how the total flux in these all directions we need to be calculated. That is called total. Then only we can set to be as d dot ds is equal to q. Okay, then so keep mind here, it's a very important task. D front is equals to d front dot ds front. That means, so here this is the d front direction, this is the d front, and this is the d back, this is the d back. See, this is the d back. So that is the back direction and this is the front direction. So what could be the ds front? It's the total emitting from this flux density from this direction, from this surface, that is called ds d front, that is d front, and dot ds front means, so this is having a surface in the direction of in the plane of dz. This is the this front face in the phase of dz and dy. So that's the area. What is the area? Dz into dy is the area in the front direction, so through which ds is emitting. That is what is called as ds front dot ds front, where ds means surface area, that is dy and dz. So what is d front? So that area in the direction of which direction? This is this dz, this ds is the area dy into dz in the direction of x direction. This is because it is emitting in this direction, that means positive x direction. So that's why d front is equal to dy dz ax, positive x direction. So where dx front, what is ds front? Dx front is direction is this dx flux emitting from this in this direction. That means we can call it as a dx, because dx means, since it is having a component of dx front, that is component of in the direction of ax. So dot dy dz ax. So that means dx front into ax dot ax is equal to 1. So dx front into dy dz. So what is d front? We need to be calculate this dx front is to be calculated. So since we have a point here, at this point what is the value in the x component? This is x component, dx naught. So dx naught. So from this component it is almost center. Center means, so from here to, so center means, so if you draw the line here, like this, this is the center. This is the center. If you draw a component on the horizontal plane, then like this. So here, so that means since it is, what is that? This value is, what is this value? Dx total. So since this is center, that means, so dx plus, that means total emitting from here to here we need to be calculated, because the from front end this much of this much of this much of this much of flux is emitting from this. That means dx naught, something is added. What is that added? The rate of change of capital dx in this direction, then this surface in the component of, in the direction of dy dz. So that's why so dx naught plus dx by 2, that means dx by 2, the half dx by 2, and something is splitted from the dx by 2, other is dx by 2 is in the negative y direction, sorry, negative z x direction. This is positive x direction. How much amount? Dx by 2 into rate of change of dx with respect to x, because it is varying in the component of positive x. So that's why, so dx naught plus dx by 2, the rate of change of dx with respect to x. So this is what is called as, this is what is dx naught plus dx by 2 dou dx by dou v. So that means d front is equal to dx naught plus dx by 2 dou dx by a. So almost this ds front is to be calculated as, means we have calculated dx front as dx naught plus dx by 2 dou dx by dou x, and we need to substitute then into dy dx. So into dy dx. And similarly dx back, so dx back into surface area back, that means dx back in the direction of ax, but because this is flux is emitting in the direction that backward, because there is a no positive sign and negative sign for dx, because the flux is emitting from this in this direction, top and bottom, left and right. So there is no negative sign and positive sign, only single value, the flux in the dx back ax. And here, but the surface area, this is the total surface area of a back end, that is dx is transmitting through or flux emitting from in the backward direction. That's why it is in the direction of minus dx dy ax component. So from that, if you multiply dx dot ax dot is equal to minus dx back ax. So then how to calculate dx back is equals to dx subtraction minus subtracted dou x by 2 dx by dou dx by dx. That means this is we are subtracting, because this part is we are subtracting this. Initially we have a start from here, total dx by 2 added this much. Now we are subtracting dx minus dx naught minus this much amount of subtracted. Then what is the dx by 2 rate of change of dx by with respect to dx? That means here dx by 2 means del x by 2 dou dx by dou dz. Then so from this dx back is equal to dx naught minus dou x by 2 dou dx by 2 and dy dz minus. So from this, so this is equal to minus dx naught plus dou x by 2 dou dx by dou x dou y dou z. That means now total amount of flux from dx front plus dx back is equals to, so see, this is a dx front and this is a dx back. So after adding these two gets cancelled, then finally dou dx by dou x means del x by 2, two halves. So two halves means becomes dou x. That means so total value is equals to dou dx by dou y dou x dou z. So similarly, the front back is equal to dou dx by dx dy dz del y del x del z. Now similarly, top is equals to dx top dou s top. This is top. This is top. So through which, since we have s, if you add like this, and this much of from top means this is half. This is half. So this amount of flux from here dz naught it is plus added because it is going top means, so del x by del do means del z by 2 is added. Similarly bottom means subtracted from del z by 2. So here if you observe dx naught dou z by 2, the rate of change of dou x by dou z by, because the rate of change of dou z by dou z del y del x. So similarly bottom means we are subtracting in the case of primary one minus dz naught minus dou z by means del z by 2 dou z is simple. And if you add like this top bottom, so that means dou dz by dou z del x del y del z. Similarly left and right is equals to dou dy by dy del x del y del z. So total, so the sum of the total all the directions means dou dx by dx plus dou dy by dy plus dou dz by dz del x del y del z. Now so finally surface integral d capital D ds is equals to q. So dou dx by dou x dou dy by dou y plus dou dz by dou z del x del y del z. Already we know that del x del y del z is equal to rho v volume integral, rho del v means del v volume. So from this, like this we have written, that means, and if you take it this into bottom, that means integral d ds by rho v is equal to dou dx dou dz divided dou dy by dou v dou dz by dou z. We know that d dot ds equals q. So now it is replaced with q. So q by del v is equal to this thing. Already we know q by volume integral is nothing but rho v. So rho v. Now rho v is equal to q by v. So from this del v is equal to dou dx by x dou dy by dou v dou dz by dou z. So this is what is called as the divergence operation. Now we can write this as del d. That means rho v is equals to del d. This is what is called as the divergent. This is how we derived a total flux density from top, bottom, summation of top and bottom, left and right, and front and back. Thus, it comes to dou v is equal to divergence